Well, hey everybody, Mr. Reese back with you. And today we are going to be looking at the Pythagorean Theorem. All right. So the Pythagorean Theorem is a formula that allows us to find distances that are not vertical or horizontal distances. And we're going to be using right triangles to start off here, and then we will later be getting into something called the distance formula. All right, for right now though, we're just looking at right triangles. A right triangle is a triangle that has a right angle. Remember, the sum of the angles of a triangle is 180 degrees. So, and a right angle is 90 degrees. So that means this angle right here is 90 degrees. The two sides of the triangle that together make that 90-degree angles are called make that 90-degree angle, there's only one of them, are called legs. So this is a leg and this is a leg. And then the third side of the triangle, the side of the triangle that is opposite here, if we were to go across here, let me get an arrow. So when you go from the 90-degree angle across, that side there is the hypotenuse. Okay? So we have two legs and a hypotenuse. All right? When we label these, we refer to the first leg as A, the second leg we refer to as B, and the hypotenuse we refer to as C. By the way, they are interchangeable, the legs are, so I could make this leg A and I could make this leg B. It doesn't matter, but what is not interchangeable is the hypotenuse must be C. All right, so label whichever leg you want, A or B. The hypotenuse is C. And there is a relationship that is true, and it says that the length of the first leg squared plus the length of the second leg squared is equal to the length of the hypotenuse squared. Or as we fondly refer to it, A squared plus B squared equals C squared. And so what the Pythagorean theorem allows us to do is find the distance between 2 points that are on a diagonal segment, because that's what's going to happen here. We're going to get a diagonal segment, right? If we take a look at this leg is vertical, and we can simply subtract to find that distance. This leg is horizontal. We can simply subtract to find that distance. But the hypotenuse is diagonal, so we must use this relationship. A squared plus B squared equals C squared. All right, so for these problems, you're going to want to have a calculator handy, and you're going to need to know how to find the square root. All right? So in fact, let me real quick write this down, okay? If A squared plus B squared equals C squared, if you want to know what C is, then you take the square root. All right, so if A squared plus B squared equals C squared, then the square root of A squared plus B squared is equal to C. All right, because we're usually trying to find C, not C squared. All right, so we will actually be using this right here. C is equal to the square root of A squared plus B squared. All right, so it says find the length of the missing side. Well, this missing side is the hypotenuse. It is C. Now, again, we can label either one of these A or B. You can see that they labeled 24 as A and they labeled 7 as B. All right, so 24 squared plus 7 squared is equal to C squared. So they're simply putting in that formula. Well, 24 squared is 576. All right, so let's make sure on the calculator you know how to do squared and square root. So on most scientific calculators, when you want to square, they have an x squared button. All right, remember squared means times itself. So I could do 24 times 24 to get 576, but it's usually easier just to use that squared button. So 24 squared is 576. 7 squared, again, would be 7 times 7, but better to do 7 with the x squared button, and we get 49. All right, so you can see 7 squared is 49. If I add those two together, if I add that 49 plus the 576 that we got before, then I get that 625. So I add these two together and I get 625. Now notice 625 is equal to c squared, but I don't want c squared, I want c. All right, and then we take the square root of both sides. It's interesting to me that they did not show it. So I'm going to take the square root of 625 is equal to the square root of c squared. Well, the square root of 625 is going to give me 25, and the square root of c squared is going to give me c. So again, if I go to my calculator, I've got 625. Now here's my squared button, right? Do you see the little yellow there? So if I press the second and then that, I get the square root, and I want the square root of 625, and I get 25, which, by the way, we could check our answer, right? Because if we were to do 25 squared, we would see that we get 625. All right, so the answer for this is 25, so the length of that hypotenuse is 25. All right, so 7 squared plus 24 squared is equal to 25 squared. A squared, whoops, I guess we did it the other way, huh? Let me do it the way they did it just to be consistent. 24 squared plus 7 squared is equal to 25 squared, right? 576 plus 49 equals 625, but we weren't looking for c squared, right? That's c squared. We were looking for c, so we have to take that square root, the square root. So we're using this right here. C is the square root of a squared plus b squared. In fact, let me just show you on your calculator. If you want to save yourself some time, you can actually just start that way, right? So I'm going to start by putting the square root, since I know I'm going to have to take the square root. So I'm going to do the square root of 24 squared plus 7 squared. See, whoops, see how I have that? I'm going to close those parentheses, the square root of 24 squared plus 7 squared. And there's my answer, 25. So it's actually faster if you start with the square root, but you could do it either way and get to the answer. All right, let's do another one where the hypotenuse is missing. This example right here. I've got 30 and 40. It says find the length of the missing side. The length of the missing side is C. I'm going to go ahead and label this as A. I'm going to label this as B. All right, and I'm going to show you both ways. We're going to do a squared plus b squared equals c squared, and then take the square root. I'm also going to show you how we can simply do it a little bit faster. The square root of a squared plus b squared is equal to c. All right, so here we go. So this way is going to give me 30 squared plus 40 squared is equal to c squared. Well, 30 squared, I don't need a calculator because I know what 3 times 3 is. 900 plus 1600 is equal to c squared. Well, 9 plus 6 is 25, so I get 2500 is equal to c squared, right? So now I'm going to go to my calculator. All right, so I have, in fact, let me put it in the calculator just to confirm this process. So we've got 30 squared, there it is, right? Plus 40 squared. I'm going to put those two together and I get 2500. Now that's what c squared is, but now what do I have to do? Now I have to take the square root. I'm out of space over here. Square root of 2500 is equal to the square root of c squared. All right, so in my calculator now, I'm going to do the square root, second squared, of 2500, and I'm going to get 50. So c is equal to 50. All right. Now again, if we wanted to do it a little bit quicker, we would put the square root part first, and we're just going to start the square root of 30 squared plus 40 squared is equal to c. So let me show you what that would be like in my calculator. I'm going to start with the square root. All right, and then I'm going to put 30 squared plus 40 squared. I'm going to close those parentheses, so I'm taking that whole square root, and I get 50. All right? It really is the same process. It's just the second way you're saving yourself some time by starting by putting the square root at the beginning, since you're always going to have to take the square root when you're doing these problems. All right, so that is how you use the Pythagorean theorem to find the missing hypotenuse. All right, but what if the length that is missing is not the hypotenuse, right? So if you take a look at this next example, here's the hypotenuse, right? And this one right here is either going to be A or B. Now I'm looking, they chose to call it B. We certainly could have called it A if we wanted to. All right, so here we go. All right, so we've got A squared plus B squared equals C squared. So notice that they put in 12 there. For B, they put in 15 for C, and we get A squared plus 144 is 225. Now, this is an equation, right? So I can subtract 144 from both sides. Remember, my goal is to find that missing value. So I use inverse operations. I get A squared is 81. And again, now I'm going to have to take the square root of A squared and the square root of 81. And then I get A is equal to 9. Right, because the square root of A squared is A and the square root of 81 is 9. So our missing side is 9. So we know that 9 squared plus 12 squared is equal to 15 squared. All right. Okay, now, I wouldn't be a good math teacher if I didn't tell you there's actually kind of an easier way to do this. And we can figure out the formula. This formula right here tells us how to find C squared. But in this case, we wanted actually to find A. We weren't looking for C squared. We were looking for A, and sometimes we want B. So you know before how we had this formula right here where I said C was equal to A squared plus B squared? Well, we can do the same thing now with A and B. All right. You notice here how we had to subtract away that 144. What we were actually subtracting away was B squared. So let me show you real quickly here. All right. So if A squared plus B squared equals C squared, if we subtract away A squared from both sides, we get B squared equals C squared minus A squared. And then if I take the square root of both sides, what do I end up with? B is equal to the square root of C squared minus A squared. And of course, I could do the same process, but instead of solving it for B, I could solve it for A. So this is minus A squared. So this time I could take away B squared from both sides. And then I get A squared is equal to C squared minus B squared. And then I get the square root of A squared equals the square root of C squared minus B squared. And what do I end up with? A is equal to the square root of C squared minus B squared. All right? So you can see that we get actually 3 different formulas from the Pythagorean theorem. One that tells us how to find A, one that tells us how to find B, and one that tells us how to find C. Remember, the one we had originally was that C was equal to the square root of A squared plus B squared. So if you want to find C, if you want to find the hypotenuse, you use this formula, square root of A squared plus B squared. If you want to find either one of the legs, A or B, you use those. So these 3 highlighted in green formulas all come from this original, let's highlight it in magenta formula, A squared plus B squared equals C squared. All right, so I'm going to try to model that for you as we find a missing side here. So let me go ahead and see. This example right here, you'll notice this is our hypotenuse, it's C. This right here can be A or B. I'm going to call this one A. I'm going to call this one B. All right, so B is the one that we don't know, but take a look back here. All right, I guess, wait, if I go over here, is it still there? There it is, okay? So if we're trying to find b, b is going to be the square root of c squared minus a squared, all right? So b is going to be the square root of c squared minus a squared, all right? So b is what I'm trying to find. Remember, c is always my hypotenuse, so that's going to be 41 squared minus 40 squared. By the way, just a quick note, 41 squared minus 40 squared is not 1 squared. You can't work math that way. You have to square them separately. All right, so let's go to our handy-dandy calculator. All right, you are definitely going to want to use a calculator for these problems. So I'm going to start by doing second x squared to get my square root symbol. Then I'm going to go 41 squared, that was my hypotenuse squared, minus my a side squared, that leg squared. I'm going to go ahead and close off those parentheses, so I'm square rooting that. And when I do that, what do I get? I get b is equal to 9. All right, so what do we know? We know that 9 squared plus 40 squared is equal to 41 squared. This missing side was 9. All right, let me do one more example with a missing leg side. By the way, we're just going to be working with 2 dimensions. In our next video, we'll be looking at working with 3 dimensions. All right, so this one right here, the missing side is C. This one right here, I'm going to say that the missing side is A. So to find C, C is going to be the square root of A squared plus B squared. All right, so C is going to be the square root of 4 squared plus 8 squared. So C is going to be, I'm going to go to my handy dandy calculator, clear out what I have. Here I go. Second x squared to get my square root. 4 squared plus 8 squared. Close the parentheses. And I get that C is equal to. Now notice it didn't come out as a whole number, and the directions say round to the nearest tenth. So remember, when you're rounding, the first value after the decimal is tenths, then hundredths, then thousandths. So to round to the nearest tenth, I'm going to go to the 10th place and then 1 to the right. And I look, if it is 5 or bigger, I round up. If it is 4 or smaller, it stays the same. So C is going to be 8.9. And by the way, this one has units. It was centimeters. Did the other ones have units, by the way? They did. Bad, Mr. Reeves. B would be 9 inches. When there are units, you should put units on your answer. All right. So notice they didn't. This would be centimeters. So just a reminder, anytime the problem has units, all right, so this would be 50 feet. Make sure you're putting those units on. I'm going back because I just want to make sure I'm being consistent here. This would be 25 inches. Notice they put it in their answer. So if the problem has units, make sure that you are putting the units in your answer. All right, I think it's one more page. There we go. So 8.9 centimeters rounded to the nearest tenth. Sometimes when we're rounding, what we do is we put a little squiggly for approximately equal to. All right, last one. Here we go. I'm trying to find A. A is going to be equal to the square root of C squared minus B squared. Notice when we're finding a leg, we subtract, as opposed to when we're finding the hypotenuse, then we add. Okay, so here we go. A is equal to the square root of, all right, 14 squared, my hypotenuse squared, minus the leg squared. All right, here we go. I'm going to go back to my handy dandy calculadora. I'm going to clear it out. All right, and I'm going to put square root, second x squared. I got my square root. 14 squared minus 8 squared. Close those parentheses, and I get 11.489. It says round to the nearest tenth. Again, I'm going to make this right here squiggly because it's approximately equal to. All right, nearest tenth, I go one place, and then I go to the number to the right of that. It is 5 or bigger, so this is going to be rounded to the nearest tenth, 11.5, and the units this time are inches, because we're always going to put units when the problem has units. Okay? All right, so that, ladies and gentlemen, is just an introduction to using the Pythagorean theorem to find missing sides. As I said, we will be doing some more complex problems where we look at the Pythagorean theorem in 3 dimensions, and also be looking at something called the distance formula, which is an application on the coordinate plane of the Pythagorean theorem. Until next time, have a great day.